Assalamu alaikum. I hope all of you are doing well. In today's video, we will be solving this electricity question of May June 2006 9702, question number 34. Let's begin. The diagram shows a low voltage circuit for heating water in a fish tank. So there is a tank in which we have a source, a heater as well. So it is dipped in water. The idea is a resistance of 3 ohms, alright. The voltage source has an EMF of how much? Total of 12 volts. And internal resistance, most important thing, of 1 ohm, right? At what rate does the voltage source supply energy to the heater, right? So in this specific case, he is not demanding us to find the voltage, but he wants power because the units are in watts, right? So, let me tell you how to understand that we need to find the power. First of all, we have learned formula in O levels or in AS as well that E equals to IVT, right? Current, voltage, and time. And remember, whenever there is word rate comes, it always means time. So, right? Secondly, we know formula P equals to IV. So what we will do is energy equals to this will equals to power. Energy equals to PT. Power equals to E upon T, right? So now we know that he's talking about power. Basically, voltage determines how much energy each unit of electricity carries. On the other hand, or you can say the simple definition for power is how fast the energy is consumed. The energy is consumed. The formula for power is, right? It means how fast, at which rate, at what rate the energy is consumed, right? So this was the key concept. Now I'm just removing it to solve the question. So now we know that the concept for power. To make the things more easier, examiner has given the unit in watts as well, right? So let me just solve it. We will use formula for E equals to I R plus R, right? Where small r shows internal resistance, capital R shows external resistance, I means current, E means total EMF. So we need to find current because that's how we will find power actually. So if we make current subject, I equals to E upon R plus R. How I know that I need to use a specific formula? Because the information given in the question is in it, right? All of the required things are used in this formula. So total EMF is 12, external resistance is 1, internal is 3. 12 upon 4 will be equals to 4 on the 4, 4 to that 4 here 12. 3 ampere will be your current, right? Now we will move further and use the formula for power. We have power equals to IV, power equals to I square R, and power equals to work done upon time. We have a lot of formulas, but what to use here? As you know, there's a common sense that we don't need to find a voltage. So this will not be used. This is useless because we are not given energy here. On the other hand, the formula remains is power equals to I square R. Where we know the current, we have already found it, and we know the resistance, right? So that's how I know. Let me just remove this. Power will be equals to I square R Current will be equals to 3 square into resistance. Alright, so one thing that you absolutely need to know that this R will be equals to external resistance, right? You can never use internal resistance in the place of this R, right? It is stated in the question that internal resistance is 1. You can never use this thing. You always use 3 ohms, right? So 3 will be placed here, which is external resistance. Always use external. So 3 3 the 9, multiply by 3, 9 3 the 27. 27 watts will be your full and final answer. A will be the correct option. Thanks for watching. I will catch you guys in the next video. Till then, Allah Hafiz. Take care.